Hello, everyone. We'll give folks another minute. See if Michael's on the call. Yeah. Hi, Michael.
Hello.
How's did you guys get all snowed out in New York?
Not where I am in New York. A little bit further north and northwestern New York got hit pretty bad. We just got a ton of wind. Got the power got knocked out for like half a day.
Oh no. I'm glad to see it's back up. Are you going to screen share, Michael? Or...
Yes.
Okay.
It's actually going to be mostly Brad on my side is going to be demoing. We're gonna throw it back and forth between each other.
Okay, cool. I won't share my screen. I can paste the agenda in the chat. You can add your name at the top on the call. All right. And so we have Michael first today, Michael and Brad doing a presentation and then a discussion on the working group charter for this working group, because we started off as a digital identity working group and then expanded the scope to be the supply chain integrity working group. So README could use some updating. And just a note before we get started, if you add agenda items like each week, just make sure you put them like under whoever already put theirs at the top. I think that's the best way to do it. And then if we don't have enough time, we'll just bump things to the next meeting instead of moving things to the top of the list, if you don't mind. Cool. All right, well, welcome everyone to our supply chain integrity working group meeting. And with that, I'm gonna hand it over to Michael and Brad to kick it off.
Sure, thanks. So I'm gonna just quickly throw it over to Brad, and while he's going through the demo, I'll probably begin to share some diagrams to help walk folks through this. But just to kind of give a very quick 2-sentence sort of thing is, so we're going to be showing off the Secure Software Factory, which is a reference, or not a reference, it is a prototype implementation of what is being done in the CNCF supply chain security working group. It is it's a set of tools as well as configuration and some other things to help us build artifacts securely, whose provenance can be tracked throughout the sort of build system and so on. And I can go through some additional details as we go through. Brad, do you want to show off what that looks like?
Sure. So can you see my VS Code here?
Yep.
Okay. So this is what Michael was just talking about. So I have checked out here the Secure Software Factory from the GitHub repository. And what it includes is the infrastructure for standing up the build pipeline. So that's Tecton pipeline, Tecton chains, and also Kyverno in this case for doing the admission controlling. And a few example pipelines that we have built out. The one I'm going to show you today is called the sample pipeline. I picked it because it does a canary deployment of the build artifact at the end, which comes under the purview of the admission controller. So what I have set up here so far is basically I've run through the first few steps of the example here, basically setting up a Minikube cluster. And then the next piece that has already been done is basically installing Tecton pipeline and Tecton chains, generating some keys that Tecton's going to use using cosign, and then setting up Kyverno with an admission control policy that actually uses one of the keys from that we set up to to verify that anything that we push to, in this case, we're going to be pushing the artifact up to ttl.sh. So at the end, the governor is going to basically ensure that we only pull things from ttl.sh that have been signed by this key that we generated here. So what I'm going to do is, before we switch back to discussing the individual components, is to basically fire off the individual pipeline here. So this creates a build pipeline and then a pipeline run that runs through that, and then we'll basically start following the logs for that as we're going through the rest of the discussion. So Michael, I don't know if you want to drop back into talking about that, or if we want to, talk about what just happened with the spinning off the example pipeline run here.
Yeah, so I don't want to go too deep into that because I know there's a lot of demos that have sort of shown off some of the Tecton and some of the Tecton chains pieces, and we know kind of how some of those things sort of work together. So I don't want to go too deep in there right now, but I think it's probably maybe worthwhile just to kind of show a couple of diagrams to just show what this sort of thing looks like, and then we can kind of go back. So let me share my screen here in a second. Can everybody see the diagrams? Okay, cool.
Yep.
So the basic idea here, right, is what are we trying to do, right? What is this? What is what Brad just showed off? What is that? Well, so it's the secure software factory, right? Which is, it's a CI/CD system. It's some policy stuff. It's all these things combined to help out with helping sort of build software securely in a way who's, at least within the stuff that we're building within the context of the secure software factory, its provenance can be traced and so on. And so there's a bunch of different things here, right? It's going to require access to your source code control. So, as Brad showed, we're pulling, we're building stuff. It's going to be pushing artifacts, in this case, images to ttl.sh, but it can obviously push wherever. And it also, at some point is going to require, you want to have a production emission controller that says, hey, did this thing go through the secure software factory? Does it have valid SALSA attestations and so on? If so, then let it into the production environment. And so quickly, and this might be a little hard to sort of see, this is sort of the view of where we would love to be able to go into, where we would eventually like to go into, and I know this is probably a little small.
Yeah, can you switch to a presentation view? So zoom it a little bit.
Sure. Which is that better?
Much.
Yeah, and so the only problem with this tool is they don't make it super easy to, let me see if there's a way to switch to, don't make it super easy to move stuff around.
The text is visible, so you
okay. Yeah. I just mean, like, I want to be able to move further down the diagram here, but I'll deal with it. Okay. So the thing here, right, is so it consists of a bunch of different things. The secure software factory. So there's some build environments where we're actually building the stuff in. There is a pipeline observer, a thing that is actually recording what is happening in the builds. So it's so that it can attest to those things. It's not in there today, but eventually we imagine there to be a pipeline observer, a thing that can, sorry, not a pipeline, sorry, a workload attester and a node attester. And sorry, that's cut off at the bottom there. Let me see if I can maybe zoom here. Oh, this is probably maybe a little bit easier here. There is a workload and node attester. So these are the things that would essentially be attesting that to the identity. So this is like your spiffy spire stuff, making sure that the only workloads that are running are the ones that are pre-approved. Maybe even eventually with stuff like trusted platform module integration. we have an emission controller on the secure software factory itself. So the only things that are running are approved tasks, approved build images, and so on. And, there is, also runtime visibility. So this is stuff like Falco and so on that are sort of tracing what's actually happening in those build environments so we can detect anomalous behavior. Some of this stuff isn't there today, but quickly here, and I'll throw it back over to Brad, is today what this looks like is this, right? We have Tecton chains recording the builds that are being run in Tecton pipelines. Tecton chains is pushing attestations into OCI. It is also pushing, the Tecton pipelines are pushing images into an OCI registry. We have Kyverno enforcing policy on Tecton pipelines to make sure that only approved build images and so on are running inside of our build system. And then we have a bunch of tooling that is, essentially deploying all this stuff. And this tooling is, we help manage it through Q, which Brad will, show off. So let me stop sharing there.
Okay, so we're back. So as you can see, we've already gone through some of the stages in the pipeline, checking out the repo, and we're doing the build and push piece of it. So what happened when we did this make example pipeline, sorry, was that we basically executed this build script here, which set up a couple of variables for where we're going to push the images to, and in this case, we're going to take the default of ttl.sh, and then we give it a random repository name. So if we had multiple people running through the examples at the same time, they don't try to push to the same image location. But the meat of it is we're doing an evaluation of some Q files here and passing in some information using Q's tag capability. So what this is doing is doing an evaluation. Sorry,
Brett. Does the group are they mostly familiar at least with the general concept of Q and QLang, or do folks want to have just a quick 2-sentence sort of explanation on that as well?
A quick 2-sentence would be great.
Sure. Brad, do you want to take that, or?
You can go ahead and do it. That's fine.
Okay. Yeah, sure. So QLang is it's a configuration language that looks a little bit like JSON with some additional stuff, but it lets us easily sort of add some additional functionality into JSON that we're writing, and it can output to YAML and so on, but it lets us sort of describe a lot of these things in similar sorts of configuration languages, like your Terraform HCL or JSONet, if you're familiar with JSONet. And the language is developed by some of the folks who worked originally on the Borg configuration language and had taken some of the learnings from that and kind of expanded it into something like this. And so it's kind of just a language that's its intention is to help generate, manage, and validate configuration. Yep.
I guess the only thing I would add is that I sort of view it as a way that you can define constraints on the data and the data itself in specific values. So it generates this lattice of values that are both the constraints and the concrete data. And the key thing is that those can't be conflicting at any point in time. So you can't redefine a value to another value later on in the evaluation. And it's what it does is go through and try to unify all the different definitions in the same package and come up with whether you're adhering to that the policy and the values at the same time. And so we've taken advantage of that here. At the top level, you can import some of the Go structs to allow you to do some validation of, in this case, we're doing some of the core Kubernetes, core RBAC, and some of the Kyverno structs to do the evaluation and generation of the either the YAML or the JSON that we can then send to kubectl to do the creation of those particular items. So at the top level here, we've defined the general mappings, and the key part that we're using here is just to have a placeholder so we don't have to redefine the kind and the API versions for these things later on wherever we use them. In sort of the middle levels, so in the examples, we have further defined that in all of the examples that we want to define some secrets that we're going to be using. And then we're also going to be defining some persistent volume claims that we're going to apply across all of the pipeline runs. And so Q also has this notion of doing comprehension over, in this case, we're saying all of the pipeline runs that we've defined so far, let's add this additional information to it. And so as we walk down this tree from the SSF level to the examples, Q is going to put those together and make sure that they are consistent as we go down. And so as we get into the actual sample, this is where we get to the more concrete data sort of level. So Q has this notion of doing schema at the higher levels, policy at the mid levels, and then the actual data at the lower levels. And so that's where you can get this sort of hierarchical approach of applying the policies across there. And this is the place where we've also introduced the tags that for the repository that we saw in the shell script here. So we're doing the evaluation over the data that's in the sample pipeline tree. So that includes everything at the SSF example and the sample pipeline level, doing an evaluation over that. We're passing in this tag where we're defining the repository. And then we're using the Q command facility, which is defined in this SSF _ tool piece. And in here, we've defined an apply and a create command. So those correspond to those commands that we're using here. So here we're using the apply command to pull out everything in our definitions that will be applicable with kubectl apply. And with create, we're pulling out everything that we can use with kubectl create. So if we go back here, what that is we've basically defined a set of things so in the apply set that we say we're going to use with kubectl apply. And so that happens to be secrets, roles, that kind of thing. And then the create set at this current point is the pipeline run. So those are things that we want to create a new one of those each time that we run through it. And this is just special semantics for pulling out the inner pieces of all of those. So it's basically querying across all of the data that we've defined, pulling out all of the secret, anything that's a secret or any one of these types, pulling all those values out. And then we're basically getting the inside definitions of those, looping over those, and then we can pass that through. This is kind of a functional call semantic to do a printout using a YAML. So it streams that out as YAML. So we pull out the values of all of those things that we've defined using that sort of query, and then we're going to spit those out as YAML. And so what the script does is it pulls out all those appliables, passes it to kubectl apply, and then it pulls out all the creatables and passes that to kubectl create. Okay. So it looks like we're through the build and push phase. So any questions about that sort of Q evaluation piece so far?
So I think it might be also worthwhile just to kind of show a diagram just so that folks kind of understand the upshot of some of that. Let me
Sure.
just share that real quick. And don't worry, I'll set this to, I'll set it to presentation mode once I've shared it. All right. Okay, and I'll put this in presentation mode. Whoops. Yeah, you can see the diagram again, right?
Yes.
Cool. So quickly here, the main thing, right, is this allows a couple of different things, right? What Brad had showed off is it allows us to sort of create a hierarchy of configuration. So you can to say like, hey, the secure software factory has a bunch of rules that we believe allows you to sort of build some software securely, but we're not going to have all the rules for everybody, right? You know, you might have a step that has, you know, one person's using, I don't know, Black Duck as their scanner, another person's using some other, you know, Veracode as you know, as a code scanner or whatever, right? And so this hierarchy though allows you to sort of have, you know, the secure software factory can have a set of things that it runs, it controls. And then you can further constrain that with your own policy, your own configuration. So at an organization level, you can imagine, okay, well, we might say, hey, our organization supports, I don't know, Java, and we only support Java. So no team and no project can be anything other than a Java pipeline, right? And that helps us constrain there. And a team might have additional rules for what they require, and a project might have additional rules. And as what Brad showed is that, hey, as long as the project configuration abides by the restrictions or the constraints that the team has in the organization, it'll work. And that allows us to do a couple of things. One is it allows us to sort of enforce kind of policy at deploy time, not just at runtime. And by deploy time, I mean like, it's more like compile time, but you're not really compiling it. And it also lets us constrain, it also lets us generate a lot of this configuration because a lot of these things can be set up as defaults. If you're following all the defaults, you just get a lot of this stuff generated for you. So if I go back to this diagram here, right, the thing here is that this configuration we have, we can tie in the configuration for our Kyverno policies, for our Tecton pipelines and tasks all together. So they all get deployed at the same time, and they all are kind of considered one sort of grouping of resources. So you automatically get, you know, your admission control policy deployed along with your pipeline. You don't have to think about generating, oh, I need to have YAML configuration that looks like this, that has this string, and if that string ever changes, I need to, you know, move all that sort of stuff around. I can do sort of normal, not fully Turing complete style programming stuff, but I can do a lot with it where I import different variables and different configuration. And so all of this sort of stuff comes for free or cheap to the end user. And I'll stop sharing that. I hope that explained if anybody wasn't sure.
Okay, looks like we finished the pipeline here. So let's look real quickly at what we defined in the sample pipeline queue in terms of tasks. So we can look through this. This is sort of JSON-like, where we define the pipeline that we're going to be using here, the build and deploy pipeline. The set of tasks in there are going to be the clone the repo, build and push the image, generate an SBOM for it, do a vulnerability scan, and then deploy it to the cluster doing the canary deploy. And so you can see toward the end here, we've passed through the garbage scanner, and then it actually did the deployment to the cluster. So if we do okay, get all here, we should see a PyCalc, yeah, pod that's running. So that confirms that it got through the Kyverno scan and actually got deployed there. So the key piece here is that you'll see that we didn't have to. This is a pipeline object that was also defined at the. So if you look in the top level, the pipeline, say pipeline object has a kind that's pipeline, and the API version is this Tecton dev v1 beta 1. But you'll see, since we've defined that at the higher level, and we've said that the name of that is going to come from the name that we assign when we actually give it a concrete value. If we look back at the pipeline here, so it basically it's going to inherit all of that from the upper levels into this value. So then when we go and do the evaluation and spit it out, it's going to have all of that data already pre-populated in there. And I think that speaks to some of what Michael was saying. There are different levels at which you can insert those policies or the set of values that you're going to have for certain things. And then at the low level user end, you just need to know your unique values that you're going to be using in that case. And the goal for us is to sort of refine that, so we have a smaller set of things that the end user needs to define to do the particular operation that they want to do.
Yeah, one thing to add on there, as if folks are familiar, for example, with how some of the stuff works in Tecton, right? When you have a pipeline run, often you're between pipelines and pipeline runs, and you have you might be sharing config maps between lots of different things, and you might be generating lots of different persistent volume claims and yada yada. Q allows us to automate a lot of that, so that the end user doesn't really need to think about needing to essentially copy paste a lot of that sort of stuff.
So what I just did here is I pulled out some of the information from the pipeline run itself, and for the image URL and the tag that we used to do the push to generate a Docker image string for that, and then we can do crane on that to see what actually got pushed to the registry, and you'll see that we got one image that's tagged for 1 hour. And then we have an attestation and a signature that has been deployed into the OCI registry for that particular image. And then we can go through and do a verification with cosign of the image itself, that it's signed, and then also the attestation. And here again, we're using the secret that we generated with cosign earlier to do that verification. That's this piece here where it's the Tecton change signing secret. So if we go through and do those two pieces, we'll see that we actually have a valid signature for the image, and then the valid attestation for that too. And then you could decode the attestation to get more information from that if you needed to. So I think that's basically the gist of that particular example.
Any questions?
Current users.
So I don't think that there are any current users right now. This is, intended to be, been working obviously with the CNCF. This is stuff that we do plan to open source, or rather it is open source, but we do plan to sort of make a bigger sort of announcement for it once we kind of get all the various approvals for that. But the general idea here, right, is for us, we are using it for our own sort of use cases. But anybody is, sort of welcome to participate. We've been having some conversations with folks on, how can we expand this? Because the idea here, right, is there's a lot of examples of how to use a lot of the supply chain stuff and SBOM and Salsa and so on with stuff like GitHub Actions. But we recognize that, hey, GitHub Actions works for smaller sorts of folks. But once you're sort of a giant enterprise like we are, those sorts of things, you require a little bit more governance, a little bit more, a lot of these other things. And so we're trying to sort of build something that we think would work well for ourselves, while also maybe supporting a lot of these other use cases as well.
So it seems like the key value here is the ability to separate out these different policies at different levels, each of them imposing more restriction, well, potentially imposing more restrictions. Is that fair?
Yeah, that's one key thing. There's a bunch of other things as well that I think are a little out of the scope of this particular demo, but the idea is we also want to make the secure software factory that we've been building sort of like dog fooding all the best practices of supply chain security. So we didn't really get into it too much, but for example, we're validating, at vendoring time and also at ingestion time, we're validating that the version of Tecton that we're using is signed with the Tecton key and has valid attestations as well. And so we're working with Kyverno to make sure that Kyverno is up to date, signed, and attested. And so all the tools we want to use and included, we also want to make sure, have they been signed and attested? And we want to make sure that all of our stuff is signed and attested, and so that we could start to sort of build a better world there. So that's like one other big thing. And then another big thing for us is we also are making this like the secure software factory itself, which right now consists of a couple of these different tools. And we do want to make it eventually pluggable, so that if you do say, hey, look, I want to, replace, Tecton with this other thing, maybe eventually we could support that as well. But the basic idea behind it is, by also using Q to also configure the secure software factory itself, it makes the management of all these different resources much easier. Because you can imagine, maybe it makes sense to have a Kubernetes controller that manages all of these things, or, but then that's another thing we have to manage, and we have to, whereas with this, with some Q configuration, it allows us to say, hey, while deploying Tecton, you're making sure that, the policies you're associating with Tecton are sort of linked. And so anytime we make a change, we don't have to worry about like shooting ourselves in the foot by like, oh, I updated Tecton, but forgot to update the associated policy. All the data is, in variables and configured and so on and so forth, so that like it all gets configured as one big package, and it makes it much easier to manage.
Hey, Michael, I had a quick question, spurred from you kind of mentioning eating our own dog food with vending and such, looking at the signed, Tecton builds or even Kyverno and such. Do you have that built into the actual pipeline itself to evaluate along the way, or is that kind of like a separate exercise outside of the actual pipeline?
So right now it's there's two things. One is at vendoring time, we're validating what we're about to vendor. And so that's like, we're vendoring the Tecton base configuration, and then we're modifying the configuration through patch files so that it becomes easy to kind of see like, oh, because Helm charts can get difficult to manage and so on. So we found it much easier to just kind of pull down the releases directly from Tecton. But when pulling down those releases, Tim, who's on this call, wrote a quick and dirty tool that will validate through, right now, I think since they sign it through cosign, it validates the signatures and attestations that way. And so it'll vendor it that way. But then also one of the other things that we do as well in the Kyverno policies, and we're still developing some of these things out, is that at runtime as well, we also have policies that validate that, hey, at vendor time, we're validating to make sure that if I'm pulling in a new version of this tool, is it still, am I pulling down one that's signed and attested by the maintainers? And then secondarily, and then when I'm actually running this thing, did somebody try to replace the image without, and it's not a signed image anymore, something like that. So that's how we're kind of approaching that problem.
Cool. Thank you.
Can you talk about the keys used with cosine and how strong they are, and can you touch back on that again?
Brad,
And
do you want to take that
also-
one or?
So basically we're just generating the keys using cosine and then putting those into just for the purposes of the example pipeline runs. So we push the both the private and the public keys up into the secrets, and then we can pull them out, at least the public key out to do verification, at least for this particular example. Ideally, you'd probably have another mechanism for longer lived keys that you might use for that particular piece. We haven't put a lot of infrastructure in place for that yet.
Yeah.
Okay.
So long term, what we do want to do is we want to have those be spiffy identities. And so we would have a mechanism, and most likely we'd use something like HashiCorp Vault to integrate with that, and then we would provide keys to to Spiffy and Spiffy Spire, and then it would generate identities, short-lived identities, for us to then use and sign the stuff with.
Okay, that makes sense. So mainly just a placeholder for now, but you could theoretically replace that with something user-based, or like you said, with the Spiffy long-term.
Yeah, and in fact, a lot of that stuff that's already in there can just sort of use any Kubernetes secret. We're just, obviously, it's much easier to sort of show, hey, we're generating a key via the command line. This is, and to just show you that it's signed with this key. But it could be, HSM, it could be.
Okay, cool, thanks.
Cool. Thank you, Michael and Brad, for that demo. This is awesome. I think we need to move on to the next agenda item. And so if folks have more questions, maybe ask in the chat or find us in Slack. All right, Kay, do you want to start?
Sure. Let's see. So why don't I share the screen? And so I volunteered in our last meeting to create a draft of a new README for our supply chain integrity working group. And I did share that out by email to our list. I thought I would just maybe walk through the kind of the flow that I have for it, get people's ideas here, and then we can think about next steps. I think if we feel like it's heading in the right direction, if there aren't too many comments, we can turn it into a pull request. If there are lots of comments, we can continue iterating. So I broke it into kind of 3 areas. One is an overview of the sort of the working group. Another is information about how to get involved in the working group, and then some information about operations. Maybe the operations section could be part of overview. We could think about that. We probably want this README to be consistent with other READMEs, and I didn't spend a lot of time looking at other working group READMEs, so that might be a pass that we'll want to do, and maybe David Wheeler, I think if you're here, you can help me with that.
I am here.
Thanks, David. Perfect. Yeah, so I have an objective section and then a little bit of motivation and overview. We might even be able to collapse what I had as objective and overview. Let's see. And then I did spend a little bit of time talking about user stories related to supply chain integrity. So policy managers, kind of, I put names to each of them and then said what it is that what their needs are. Policy managers, producers of software, auditors, procurement managers, and consumers. Then I mainly copied and pasted the meetings and communications and notes sections from the previous README. And then also from the previous README, there were some sections that talked about governance, chairs of the working group, and our antitrust policy blurb. And there are a couple places where we say that we're following guidelines provided by the TAC, and I wasn't sure if we had. I'm hoping there's a document somewhere that we can link to for these. So I put places where I think we need some links. So that's the state it's in right now. One thing, when I wrote it initially, I was trying to be broad about supply chain. And I was thinking not to scope it intentionally to open source software, but think of, what we're doing is, thinking about supply chain all up that applies to open source and proprietary, and potentially even to things that are not strictly software, like firmware and cloud services. And Dan had suggested maybe we want to keep the scope to open source software, and that's totally fine with me. So I did change it in one place. Maybe we need to add the words open source software in other places in here.
Yeah, I think your current objective says we're going to solve it for bananas, and because it doesn't say it's even IT, never mind software, never mind open source software.
And
Yeah.
it's called end-to-end supply chains for. Is that better?
Sure.
Well, and given that open source ends up in lots of other types of software, that doesn't preclude us considering those impacts.
Yeah, I wouldn't mind expanding this to software more generally, at least in the sense that open source software ends up in the proprietary, and we want to help those proprietary software users. I'm just concerned about extending it to non-IT, because if we start all supply chains, we'll be here a long time.
Yeah, I was pretty happy with what Dan had suggested, which is focused scoping to open source, because that's what the foundation scope is on securing the open source ecosystem. So, but I don't think that precludes us from doing things that are, that apply to open source and other things. It just says.
Well, I think your ecosystem implies those that consume open source, which opens the door to everyone else.
Okay, so Bob, you're just saying that it sounds like you're agreeing that it's okay that it says open source software here, acknowledging that still we still have to support those who use it within other contexts.
Yes.
Yeah.
So ecosystem catches that.
This is a point I've made in discussions about Log4j's integration into commercial products as an example, where we have to enable the tracing of supply chains of open source, no matter where they are integrated and then sold.
I might suggest that the user stories not be in the README file, but in a separate file linked to, because this gets kind of long.
Yeah, I was thinking about that as well. So, yep, I can see that.
Not objecting to the content, more the
right.
Just
That way you can churn the user stories without churning the
main README.
I don't mind changes to the README if it's an improvement.
I agree, though. I think we wanted to try to keep the README crisp and focused. So that's good.
Yeah, we should figure out how to keep some of the content from the existing README too. There's a lot of good work early on, like a threats diagram and things that we were trying to initially protect against, and different types of attacks and goals and non-goals. So I don't think it has to live here, but I'd hate to see that going away. I know that was some concern that people had with even rescoping this working group, is we don't want to lose sight of some of the other problems that we initially set out to look into. So I'm not sure if it's just another doc, maybe we can throw somewhere, but.
Does that make sense to folks? Maybe a linked document?
Seems easy enough for now.
Right, yeah.
I don't know if
One
Gavin's
thing we
on the
didn't
call.
really do is talk about scope in terms of, and that's a possibility. We didn't talk about scope in terms of the aspects of supply chain that we're concerned with. So things like, you know, and this is what the previous working group was one aspect, which is developer identity. And so now we've expanded. We're also thinking about policy and attestations, and so maybe we can add a section for that. And then I don't know, let me think about it. I was thinking we could add a section for sort of areas of supply chain covered, and then have a link to develop the previous developer identity attestation from there. Maybe let me play with that, if that sounds good to folks. And maybe I can make one more pass at this. We can discuss it in our meeting 2 weeks from now, and then think about going to a pull request after that.
Can I suggest moving a little faster? Because I mean, currently I think the README is terribly misleading, and I'd hate for the best to be the enemy of the good. I would propose just turn this into a pull request now. Put the user stories in a separate file, link to. We can still make use the pull request comments to comment on tweaks for it, and then merge it in, and then keep making improvements. But I'd hate for it to linger too much longer. I think people are very confused by the current README.
Yeah, I think that sounds good. I think there was a comment in the chat about the objective, so take a look at that. Okay, maybe one more recommendation.
Sure, let's see. Sorry, I had my oh, okay. Okay, so do we, so, okay, currently the overview and the objective read pretty close. Do we want to get rid of them and just have?
Yeah, because you have nested overview headers too.
Yeah, so maybe we just have, maybe we take what is currently the overview and make it the objective.
Yeah. Yeah, I hate to have duplicates. I mean, you could take the overview and text. The objective mentioning the supply chain integrity working group, starting out with that, is not a bad thing anyway.
I guess it's like the objective.
The supply chain integrity working group's objective is to provide a
Yeah, you can just remove that objective header and just leave it as the top level.
We can deal with this in the PR, but if you do that, you're going to lose DSS and ensure verbs.
Kay, can you post the URL in the chat, and maybe we can just quickly offline beat on this, get a rough agreement, and then create a pull request from it.
Cool. Sounds good.
Okay.
Thank you, Kay.
You're welcome.
We have a few minutes left, and I don't think we've done intros in a while. So if anyone is on the call and wants to say a quick hello and what you're interested in solving or helping with, that would be awesome. But if not, no worries, and we can end a little early.
Sure, I'll go. Hello, my name is Nathan Menhorn. I'm from Xilinx. One of my primary focuses is on software security. So I've recently joined this group just to kind of look around at the different groups and, you know, see what's interesting and then kind of go from there. So if I have lots of questions, that's it's because I'm new. So apologies.
Okay. Yeah, we have a Slack channel too. It's not too active, so feel free to throw questions in there. There's a lot of people in there too.
Thanks.
Yeah.
I'll say hello. My name's Tom from Bloomberg. Very interested in open source software supply chain, especially the amount we integrate with it. I went to, I think, the Salsa working group last time and just trying to see which groups we can help with and will help us as well. So yeah, a novice finding his way around at the moment.
Awesome. Welcome.
Hey, I'm Wietse Venema. I work at Google. I recently joined a small group of people who work on software supply chain security, Salsa. And sorry for the audio trouble that I caused at the beginning of this meeting.
No worries. Welcome.
Yes,
Yeah.
we're very glad you're here.
Cool.
On the next then. Nice to meet you, folks. I'm Mickey. I'm from SNCC's Office of the CTO. In my role, also, I'm working on the supply chain strategy. So we're looking to learn how we can collaborate with the OpenSSF Foundation.
Awesome. Welcome.
Thank you.
All right.
So if that's it, I would propose let's go back and show the objective one more time because we have a minute. I think we have a few little tweaks right now, trying to merge the old objective and overview. Can folks more or less buy into this? I mean, we've been talking about it for a while, but it's always tricky to turn this into text.
I think it looks good.
I like it. Thanks to whoever called out the assess and the assess verb, I think is important.
Yep.
The question on the quality, are there other working groups or anything to assess quality? Quality seems subjective in open source. There's some really good stuff and then we'll say not so good stuff.
You know, it's a great question, Nathan. And I think that the answer is best left to the working group's actual output rather than trying to pin it down in the mission. You know, you're right, it's in the eye of the beholder. From my perspective, you know, we are in the context of quality in so much as it affects the security risks of a piece of software is sort of where my brain is, but that's a lot of words to try and mash into something where there's a lot of parent context anyway.
Can we just replace security, quality, and integrity with the word integrity? Because usually the definition of security includes integrity. No.
Categorically, no. I'll explain my perspective because I'm so dogmatic, David. You know, to me, there's three problems of software supply chain, right? There's correctness, aka quality, as in, was this thing well made and does it resist the kind of attacks that would come? Like, is it resistant to attacks by how it was made? Integrity is free from tampering, where having been written down by amazing engineers, did somebody find a way to inject weaknesses into it such that it can be attacked once it's used? And then availability, well, I don't think I have to say more than faker.js to talk about availability problems or leftpad, but distribution of all these things also fits into that bucket. But there's a big difference between a vulnerability where, whoops, we have a bug in this and we didn't mean to do this, and somebody found a way to inject something into it somewhere along the process, whether it's compiling or in the source repo attacks or whatever. That's, to me, is the difference. So that's why I'm not comfortable just using the word integrity. Internally, we've actually stopped using that word when we talk about the broader umbrella, because integrity very much means free from tampering or unilateral access or something like that.
Yeah, I was actually saying just the word security because typically the word security is defined as confidentiality, integrity, availability.
Oh, I see. Oh, I thought you were saying integrity. I'm completely.
No. Quite the reverse. Quite the reverse.
Oh, okay.
You know, and you know, we could say ensure the security, including the confidentiality, integrity, and availability.
I'm just looking at Santiago's comment. I'm trying to see that properly. Hang on.
Asking a group to figure out its own objectives is always a challenge.
It is, yeah.
I mean, the pun intended, Santiago, in terms of security pointing to the CIA. Is that where you're going with this?
Oh, the CIA triangle is well known, and I think it's easily remembered in part because of that.
Yeah.
You know, maybe I can just I'm going to put it in suggestion, confidentiality, integrity.
I hate to be the person who points out that confidentiality usually implies confidentiality, which seems at odds with public information about the open source supply chain.
Actually, it's not, because there are keys that must be kept confidential, even though the source code is public.
But to me, like, we've lost my correctness piece. Like, where would you describe a vulnerability here? It's not an integrity in my book. That's sort of the, like, integrity means nobody's messed with this thing. It hasn't been tampered with. It is what we said it was. But a log4j problem is not a confidentiality problem or an availability problem. It's a correctness problem. So maybe I'm maligning the CIA triangle, but I have subverted it to mean correctness in my context.
Well, and that's important when you get into safety. So you need it to be safe, secure, reliable, resilient.
Yeah, the CIA triangle usually also refers to the data being managed, not just the code itself. In other words, the problem with log4j is that it subverts the integrity of the logs it produces, as well as the systems it run on it, and confidentiality of them as well.
Can we just say security? Just
keep it
checking
simple.
that again. I mean, we could get into lots of adjectives to describe it, but maybe for purposes of the overview, could we just say security?
I think the bike shed should be pink for maximum visibility and distance.
The other nice thing about using security is it maps with open source security in our foundation name. So.
And to Ava Black, on the correctness perspective, it's a great question. It's in the beholder at some level, but yeah.
Yeah, I think we should be careful that objectives don't, you're never going to get everything in a short sentence.
Right.
Right. And I love Jose Miguel's suggestion that we effectively put all the bike shedding in a separate document where we can party on that and explore it in a more philosophical bent rather than trying to sort of, count the number of angels on the head of a pin. So,
yeah.
Okay.
So my only concern with that is an outsider who's really worried about, medical or, safety critical equipment would read this and think, oh, they don't care about my problem. And that's not true.
What word would you add to make them care about it? Like, is it safety?
Well, the three I tend to go with is security, safety, and reliability, which, just seem to stretch a little different in user land.
I don't know that we would want to say that we were taking on reliability
or safety.
And like safety feels like yeah, I don't know. Maybe we should have a separate conversation in the bike shedding document to really explain that. And then I think that it would be worthy of a conversation, and then moving it up as parentheses sort of, behind security after we've had that conversation. But, and I mean this with I'd like to learn more and understand more, but what would we do towards safety? And somebody asked about what does correctness mean, right?
Well,
Like,
so safety ends up being a bit of correctness, a bit of integrity, a bit of security, but packaged together a little differently.
The issue isn't that. The issue is this group historically has not been focusing on, say, safety, but instead on the security. I mean,
Well,
you
and
can look at
that's
the name.
societal, you know, and broadly speaking, though, that's the problem is a lot of people have put software into safety systems, and the people who are trying to help mature software haven't necessarily been, you know, thinking about that. And so we end up with unsafe, yet maybe secure systems.
Let's, so we are at the top of the hour, people are bouncing. Let's, you know, it feels like this is an okay starting point. Let me put in a pull request, and I think we should keep, you know, refining. I think we can refine in a couple ways. We can have what we talked about as the bike shedding document, but we can also, you know, add more user stories to cover different scenarios and be clear about, you know, the things that we care about. So just in the interest of what David pointed out, let's try to make the README better than it is today as a starting point, and we can keep refining.
thanks very much for this.
Okay. Thanks, everyone.